Hello and welcome back to my channel where we talk about my adventures making an FM synthesizer and a sequencer, including tutorials and design decisions and various follies. And today we're talking about the sequencer side of things, so let's get into it. So just to remind you how a tracker works, which is a type of sequencer. So here's Pro Tracker from the 1990s, and you have your notes arranged in a grid, and as it scrolls, they play. Okay, so now let's get into the design of my tracker. So we looked a little bit at the work so far, the work produced so far last time, and now we're going to go into a bit more detail and discuss what some of the potential limitations of this paradigm could be and how you get around them, including the subject of what are ticks. We'll definitely get to that. So we've got some maths to get into first, but I promise it's not too hard. So we've got a number of concepts that we need to define. First of all, the number of rows per beat, which by default is 4. So that means that one note is a 16th note if we assume that a quarter note is our beat. And then we have beats per bar, which by default is 4. And number of rows in a pattern, which by default is 64, which means that there's 4 bars in a pattern, because there's 4 rows in a beat, 4 beats in a bar, so that's 16 rows in a bar. 64 divided by 16 is 4. And then we have the number of rows per minute, like how fast is this thing going to scroll, which I've currently got set as default of 240. We might change that. These are all just defaults. You can change them. We'll get onto that. So if you want to know what 240 rows per minute is in beats per minute, well, it's the number of rows per minute divided by the number of rows per beat. So 240 divided by 4 means that it's 60 beats per minute. So we have these things called patterns, which is like, like kind of one sheet on a spreadsheet, and then you've got like a song, which is an arrangement of various patterns. So what kind of changes are we allowing our users to make as the song progresses? So I'm going to let people change the number of rows per beat and the number of beats per bar. You can just change that at any time, and you can even have different values on different tracks. So that means that we can have polymeter, and you can change the number of rows per minute at any time. So that's like a tempo change, and each pattern can have a different number of rows. So you can have shorter patterns and longer patterns. The things that we're keeping constant are we're going to have the same number of rows per minute on every track and the same number of rows in the pattern on every track. So that means that everything's in lockstep. So the columns representing the different tracks are always synchronized with each other. The pattern starts at the same time and ends at the same time, no matter which track you're talking about. There are some trackers that let you kind of violate these rules. One of them is LSDJ for making music on the Nintendo Game Boy. But then it's less of like a spreadsheet, kind of two-dimensional pattern with all your track laid out, and it's more like a bunch of independent columns moving at their own speeds. It offers some extra features, but it also offers, confusing kind of extra kind of just sources of confusion for a beginner. So let's consider the limitations of this tracker paradigm. So we said that by default, one row is going to equal 1/16th note. Well, then how do we represent 30-second notes? Because that's like half a row. Yeah. Can't really, the whole idea is that we put notes in these cells and lay them out in a kind of spreadsheet format. So half a row doesn't really make sense. Something's kind of gone wrong there. What about triplets? So a quarter note triplet, so that takes up the length of 2 quarter notes. Each quarter note takes up 4 rows, we said. You're fitting in the 3 notes of the triplet, so each one is going to be 8/3 of a row. So 2 2/3 rows. Getting tricky. And then a 16th note triplet would be 2/3 of a row. So the tricks that we use to get around these problems are we can change the number of rows per beat. We can use a feature called note delay, and we can use a different feature called retriggering. So we're going to go through each of those. So the first solution to get things to kind of line up on the grid, as it were, is we could increase the number of rows per beat. So if we've got 4 rows per quarter note, then that would mean that a 30-second note is half a row, and that's no good. But what if we increased it to 8 rows per quarter note? In that case, a 30-second note becomes 1 row. And in order to, if we just increase the number of rows per beat without changing the rows per minute, then we would halve the tempo. So we need to double the number of rows per minute because we've doubled the number of rows per beat to make sure that we keep to the same tempo. But yeah, that works. Obviously means your patterns are a lot longer, and if you've just got a few 30-second notes, then you're going to have a lot of empty space when you're not using that extra kind of resolution. So you might be making your grid extra fine unnecessarily. But yeah, it's a potential solution. And you could just do it for one pattern. You don't have to do it for the whole song. So the other 2 solutions, if we don't change our grid, then how do we have some kind of concept of placing notes in between notes? I've called it in between notes. In between rows would be more accurate. So in the tracker paradigm, there's an extra concept that we haven't gotten into yet. I may have mentioned it last time, I can't remember, just in passing. So each row has its own subdivisions within it, and they're called ticks. And by default, there's 6 ticks per row, but you could change that at any time. And I'm allowing different tracks to have different numbers of ticks per row, which is not normal. That's an extra feature that I've added. And so how do we use these ticks? Well, there's certain features of the tracker that make use of them. So one is called note delay, that we're going to look at in a minute. Retriggering, we're going to look at in a minute. Arpeggio, we'll come back to another time. And changing the volume, you can do it on a particular tick. So here's an example using a delay column. So we said a quarter note triplet takes up 2 2/3 rows. So if we start our first note here on row 1, and it's got a delay of 0, so it starts on the first tick. We've got 6 ticks in each row, which I've numbered 0 to 5. So we've got there's our 2 rows, and then we need 2/3 of a row extra. So if we delay this line by 4 ticks, so the D doesn't start until here, then that gets us our extra 2/3 of a row. And then similarly here, we need to delay by 2 ticks, because we've got our 2 rows, and then we've got 1/3 here, so we need an extra third here. Yeah, and we're done. That's our 3 triplet notes. So that's one way that you can use the note delay feature. The other one is retriggering. So let's use a 16th note triplet for our first example of retriggering. So a 16th triplet is 2/3 of a row, and 6 ticks per row. So 2/3 of 6 is going to be 4 ticks. So here we've got our first row, and the note is C, and then we've got the effect. And I said last time I don't expect people to memorize the technical format of how the effect codes are written. We will have a graphical interface at some point. But for current purposes, while it's still in development, because we don't have a graphical interface yet. Yeah, here's the code. So it's, like I say, this will one day become redundant once we get a graphical interface, but by way of temporary explanation. So the group of effects that retriggering belongs to is A for articulation. Retriggering is our articulation effect number 1. And then the first parameter is we want to retrigger every 4 ticks. And then the second one allows us to change the volume. I'll mention that again in a second. So we play a C on our first tick, and then after 4 ticks, we need to start a new note. So we're still on this row, so it's still going to be a C. And that goes on for 4 ticks. And then on this row, once we've finished the note that we started on the previous row, then we switch to a D for another 4 ticks. So we've got our 3 notes, 4 ticks each, spread across 2 rows like that. I should say that this graphic is potentially misleading in a way, in that each note doesn't necessarily take up 4 complete ticks, because you're probably not going to be playing like strictly legato. So we've got a whole, in terms of our envelopes, we've got a whole attack, decay, sustain, release thing going on within each of these groups of 4 ticks. So just being mindful of that. So what if we wanted to play CED for our triplet instead of CCD? So we need some way of cramming more than one pitch into a row. So one way of doing that is with the arpeggio effect, but I haven't implemented that yet, so we'll probably have a separate video on that. So for now, assume we've just got 1 pitch per row. And yeah, here I mentioned the second parameter is you can increase or decrease the velocity of the notes. Yeah, so the second C could be like gentler or softer or stronger than the first one. But in this case, we've got 0, which is no change. So here's another example. Here's how we can do 30-second notes without having to change the number of rows per beat. So a 30-second note we said is half a row, and we've got 6 ticks on a row, so that half a row is going to be 3 ticks. Yep, so we retrigger every 3 ticks. So we've got C for 3 ticks, another C for 3 ticks, and then the second row doesn't have the retrigger effect applied, so that just takes up the whole 6 ticks as normal. And here's how we can do triplets of any size. So in this example, we're going to do an 8th note triplet, which is 1 1/3 rows. So that's going to be 8 ticks. And yeah, here you can see we've got 6 ticks on the first row, plus 2 on the second row, and it just all works out. So yeah, so yeah, not all trackers support this, but yeah, I'm allowing the number of ticks, how often you retrigger, to be more than the total number of ticks on the row, which allows you to do this kind of thing. Yeah, so just writing retrigger every 8 ticks is quite easy, really. Easier than computing those delays that we were using before. Now we're going to get into some kind of tricks or like extra things you can do. So one is that you can do, you can split the row into a short portion and a long portion. So here we're retriggering every 4 ticks. So our first note takes up ticks 0, 1, 2, and 3. And then we start a new note on tick 4. So that goes for tick 4 and tick 5. But then on our second row, we don't have the retriggering effect applied. So this is just a standard row that plays for all 6 ticks, which means that this second note, the blue one, gets cut off. So that one only lasts for 2 ticks. So we've got 4 ticks, 2 ticks, 6 ticks. So I guess that might be useful. It's a little hack. And now we're going to talk about how retriggering interacts with the delay effect. So I'm allowing you to use both together, which is not a common feature in Tracker at all. Usually you can only have, usually delay is considered an effect, and you can only have one effect per row in most trackers. So here we've got C being played for 4, and then C being played again, and we're still retriggering at every 4 ticks, but because this row is delayed by 2, it means that the first 2 yeah, it means that we shift the beginning of kind of all the computations that happen on this row by 2 ticks. So these 2 ticks are where the delay is allocated. And then we carry on as we would have done before. So we started the C and we had 2 ticks up here, and we're retriggering every 4 ticks. That means we've still got an extra 2 ticks to go. So that's these final 2 here, and then these are the extra 2 inserted by the delay. So we end up with a total of 6 ticks. And then we just carry on retriggering every 4 ticks. So yeah, you can lengthen one of the retriggered notes by inserting a delay. That's one trick. Now we're going to move on to tricks that you can do using delay on its own. So you can use it just to make the timings a little bit kind of off of the grid pattern. So here we've got the first note plays for 6 ticks, and then the second one plays for 5, because the third, row 3 has a delay of -1 tick, so it means that it steals a tick from the previous row, so that has 7 ticks, and we've got another 6 tick row, and then another 7 one, because row 6 is delayed by 1 tick. Yeah. And then another thing you can do as soon as you start getting multiple tracks is that we can sort of write out the same melody, but I've shifted it up by a fifth on track 2, and I've also added a little delay. So I should have put this one into the spreadsheet so we could actually hear what it sounds like. I just did it in the slideshow, but you have to imagine. So it'll be like an echo, because it's like a sixth of a 16th note afterwards, so quite quick afterwards, and it's pitch shifted as well. So there will be a separate effect. I haven't made it yet, but there will be, a chorus flanger delay kind of effects unit. Yeah. So there's that sort of delay, which shouldn't be confused with the note delay column. But yeah, the delay process, I won't have pitch shifting. It'll be quite basic-ish, but powerful. Yeah, so that's how you do the echo with pitch shift. And that's the end of the presentation. So let's look at the actual work in progress. So here I've just loaded up the synthesizer, set up a little instrument patch, and it sounds like this. So yeah, just a brief recap of previous episodes, I guess. So here I'm using the 2 stack, and operators 3 and 4 are actually disabled, so we've just got one operator controlling the frequency of another operator. Yep, and the other kind of notable thing in this patch, I'm not going to go through all of it because we've done that in previous videos, and we will do it again in future videos when we get more parameters to play with and finer details to adjust. But the notable thing about this patch is that the modulator is using a frequency ratio of twice the frequency of the carrier, which is quite handy for making these kind of woodwind instruments. So now I'm just going to open developer tools because we don't have an interface to the sequencer yet, so we have to trigger it from here. So just a quick demo in a lower octave. And now that was just demoing the general sequencer, which I think we had that example in a previous episode, but I just thought with a new instrument patch, give it a go again. Now we're going to have an example of retriggering, because that's what we've been talking about. Right, so let's play this and then we'll open it up and have a look at what's going on. Okay. So, to get to this one. So here we've got, we start on C, and we retrigger every 4 ticks. So that's precisely what we were talking about before. Yep, so that's our triplet basically. It's going C, C, D, and then we've got our longer note E, which is actually so that's actually an 8th note because it's 2 4th rows. Until we get to our next note, which is a C again, and now we're triggering once every 2 ticks. So so we're going to have 3 notes crammed into this row, and here I've put there's a reduction in volume on each one, and then we finish that bunch. So that's the very fast bit that goes da da da. It ends on D. So that's our D. And then we have the slow bit at the end, which is where we've got triplets again, but longer triplets. So that's retriggering. And there's another example that would be relevant to today's talk. Let's try the ticks per row. So what's going on here? So here we're retriggering once every 2 ticks. So that's our A1 effect, every 2 ticks. So we're doing that on every row. But we're changing the number of ticks that exist on each row. So we start with our default of 6 ticks, and then we're going down to 4 and then 2. So it should like slow down. So let's hear that one. Ticks per row. Yeah, it's very well. It works. It's just we need to go. That should be really big timer. It's a little bug at the moment where if you load the same thing twice, it doesn't register properly. I need to look into that. Let's reload. Ticks per row. Yeah, it sounds quite weird. Yeah. But there you go. That's altering the number of ticks per array. Yeah, so that is the end of today's talk, people. Honored guests, YouTube viewers, I hope you enjoyed it, and I'll be back soon. Don't forget to like, comment, and subscribe, and I'll see you next time.